For a long time, the image of dinosaurs has been deeply ingrained in our minds as colossal creatures, living in tropical swamps under the scorching sun of a hot and humid prehistoric world. Triceratops munched on plants in fern forests, while T-Rexes stalked their prey among giant trees, all within a vibrant and colorful habitat. However, a seismic discovery in one of the most unforgiving regions on Earth has completely shattered that familiar image, forcing us to redefine not only the existence, but also the biological nature of these ancient creatures. At the Prince Creek Formation in northern Alaska, where modern life struggles to survive, scientists have found a rare paleontological treasure trove. This is not just a typical bone bed, but a prehistoric maternity ward, where dinosaurs laid eggs and raised their young tens of millions of years ago. This finding has overturned every existing hypothesis about the dinosaurs' adaptability. The small, fragile, fossilized bones and teeth of the young, including a tooth from a juvenile T-Rex that was only about 6 months old, have provided undeniable evidence that these creatures not only roamed the polar regions, but were year-round residents. The presence of juvenile dinosaurs here has posed a great and challenging mystery. How could these colossal creatures, considered cold-blooded reptiles, survive through months of perpetual darkness and the frigid cold of the polar winter? The answer to this question is not merely a discovery about behavior, but also reveals profound secrets about the physiology and evolution of one of the most successful groups of creatures in Earth's history. Footprints from the Cretaceous, unearthing ancient Alaska. To understand the survival of these dinosaurs, it is necessary to reconstruct their world 70 million years ago. Although located in the Cretaceous period, a greenhouse phase in Earth's history, the Prince Creek region in northern Alaska was still at a high northern latitude and experienced a harsh winter with 4 months of perpetual darkness caused by the tilt of the Earth's axis. The climate back then was significantly warmer than the modern Arctic. Paleontologists estimate the average annual temperature was between 41 and 50 degrees Fahrenheit, 5 degrees Celsius and 10 degrees Celsius, similar to the climate of modern-day Seattle. However, winters were still very cold, with average temperatures that could drop to 11 degrees Fahrenheit below zero, and evidence suggesting snowfall. The ecosystem at that time was not a humid tropical rainforest, but a deciduous coniferous forest with ferns, horsetails, and various flowering plants adapted to seasonal changes. For more than a decade, paleontologists Gregory Erickson and Patrick Druckenmiller led challenging expeditions to search for evidence of dinosaur life in this region. Instead of looking for giant skeletons, they used fine mesh screens to sift through sediment, a painstaking technique to find the incredibly small and fragile bones and teeth of juvenile dinosaurs. This persistence led to a discovery that astonished the entire scientific community. They found fossils of at least 7 different types of dinosaurs, all of which were juveniles or hatchlings. The most notable discovery was a tooth from a juvenile tyrannosaur, possibly only 6 months old. The finding of such juvenile fossils at a high northern latitude directly refutes the seasonal migration hypothesis. This analysis is reinforced by knowledge of the dinosaur life cycle. Dinosaur eggs have a very long incubation period, from 3 to 6 months. After hatching, the young would be too small and fragile, with not enough time to grow large and strong enough to undertake a massive migration of thousands of miles to the south before the polar winter, with its darkness and cold, descended. Therefore, the presence of the young here is not just evidence of breeding, but undeniable proof that these dinosaurs were year-round residents of the polar region. This discovery has transformed the Prince Creek Formation from a regular bone bed into a unique repository, allowing us to uncover the secrets of dinosaur life cycles and survival strategies. It affirms the importance of microscopically studying small fossils to draw major conclusions about the behavior of prehistoric animals. Dinosaur survival strategies. The debate over whether dinosaurs were warm-blooded, homeothermy, or cold-blooded, poikilothermy, has been going on for decades. Evidence from the Arctic has provided a strong and compelling argument in favor of the warm-blooded hypothesis. A cold-blooded creature, like an alligator, would not have been able to generate the muscular strength and endurance needed to hunt and survive in such a harsh climate. The dinosaurs' dominance over mammals in terrestrial ecosystems throughout the Mesozoic era can only be explained if they had a high metabolism, which would help them maintain a high level of activity and strength. However, some scientists propose that dinosaurs may have had an intermediate metabolic rate, somewhere between warm and cold-blooded animals. Regardless of the exact rate, their ability to survive year-round in the polar region is irrefutable evidence that they were not sluggish reptiles, but active creatures capable of regulating their body temperature to cope with the cold. Feathers, hibernation, and unique adaptations. The harsh environment was not just a challenge, but also an evolutionary driver. It pushed the development of unique biological and behavioral traits that became key to survival. Scientists believe that carnivorous dinosaurs, belonging to the theropod group, may have had feathers as an insulating coat to survive the winter. This trait was not a coincidence, but a vital adaptation, showing that evolution had equipped them with a feathery jacket to protect them from the cold. For herbivorous dinosaurs, their strategies may have been different. Smaller species likely dug burrows underground to hibernate, a behavior that would help them conserve energy when food sources were scarce. Meanwhile, larger ones may have used their massive body mass to retain heat, a phenomenon known as gigantothermy, and may have gone without eating throughout the winter. The diversity of these strategies shows that dinosaurs were not simple creatures, but complex organisms with sophisticated survival strategies. They are successful examples of how species adapt to environments with strong seasonal changes, which is rare among modern reptiles. Unique dinosaur species. The tiny tyrant, Nanuksaurus hoglundi. One of the most notable inhabitants of the ancient Arctic was Nanuksaurus hoglundi, a polar tyrannosaur. Initially, based on limited fossils, scientists hypothesized that it was a dwarf tyrannosaur, only about 5 to 6 meters long, much smaller than the colossal T-Rex. This small size was seen as an adaptation to the harsh environment and reduced food sources during winter. However, the story of Nanuksaurus is a perfect example of how science self-corrects. More recent studies, based on additional, not yet fully described fossils, now suggest that Nanuksaurus may have been much larger than initially estimated, with a size comparable to other tyrannosaurids like Albertosaurus, and possibly weighing over 1.9 tons. This change in understanding is not an error, but a necessary process of science. The initial data from a single specimen created a fascinating hypothesis, but newer, more complete data has forced a re-evaluation of that hypothesis. This shows the importance of continuous excavation and research to complete the picture of a lost world. Polar herd. Pachyrhinosaurus paratorum. Besides the carnivores, the Prince Creek Formation was also home to Pachyrhinosaurus paratorum, a unique-looking ceratopsian, horned dinosaur. Unlike the famous Triceratops, Pachyrhinosaurus did not have horns on its nose, but instead had a large, flat, bony boss. Fossilized footprints found in Denali National Park show that this species moved in large herds, a social behavior that may have been a survival strategy to protect and care for their young in a harsh environment. This herding behavior not only helped them defend against predators like Nanuksaurus, but also reinforced the hypothesis of multi-generational family units, a common survival strategy in modern mammals and birds. A diverse ecosystem. The fossils at Prince Creek reveal a polar ecosystem much richer than we ever imagined. Besides Nanuksaurus and Pachyrhinosaurus, scientists have found evidence of many other dinosaur species, such as the duck-billed hadrosaurid Ugrunaluk kukpikensis and other theropods like Troodon and Thescelosaurus. This shows that the ancient Arctic was not a barren wasteland, but a vibrant world where many dinosaur species developed unique strategies to survive. Changing the evolutionary map. The discoveries of dinosaurs in the Arctic, along with findings in Wyoming, have completely changed the scientific community's previous beliefs about the origin and distribution of dinosaurs. The popular view that dinosaurs first appeared in Gondwana, the southern hemisphere, and gradually migrated north to Laurasia has been challenged. New evidence shows that dinosaurs appeared in both hemispheres at the same time, much earlier than previously speculated. This discovery not only rewrites a chapter in the evolutionary history of dinosaurs, but also proves that they were extraordinarily adaptable creatures, capable of thriving in various latitudes and diverse habitats. In conclusion, the discovery of Arctic dinosaurs has provided a new perspective on their nature. They were not just limited to tropical regions, but could also survive and multiply in environments with seasonal changes. This ability is supported by strong evidence of a high metabolic rate and complex survival strategies, more akin to birds and mammals than to modern reptiles. Studies also indicate that the ecosystem here had lower species richness compared to temperate regions, suggesting the existence of a distinct biota province in the polar region, named the Panaktat province. Although many mysteries have been solved, this discovery also opens up new questions for future research. Scientists are still searching for more specific evidence to precisely determine which species hibernated, which had feathers, and their detailed physiological mechanisms. What happened to this unique ecosystem when the Cretaceous period ended and the non-avian dinosaurs were wiped out? These questions are driving future expeditions and research, promising to bring even more spectacular discoveries. The discovery of Arctic dinosaurs is not just a milestone in paleontology, but also a reminder that the history of life on Earth still holds many mysteries waiting for us to unravel. If you are also passionate about stories of life and evolution like we are, join us. Press the subscribe button now so you don't miss the next great journeys of discovery, from the deepest oceans to the most distant stars. And now, we want to hear from you. Which Arctic dinosaur impressed you the most? Do you think they still hold other secrets yet to be revealed? Leave your comments below so we can discuss together, because the journey of discovery is never a solo one. Hello, and see you in the next videos.